Hi there, this is Ms. Page. Welcome, I'm glad you're here. In this lesson, we are going to talk about how to find any of the 6 trigonometric values for our unit circle angles. So we have previously talked about and learned that each of the points on our unit circle, the x-coordinates represent the cosine value of the angle that terminates in that position, and the y value of the point represents the sine value of that angle. And we've talked about that in each quadrant then, because cosine is x and sine is y, the sine, meaning positive or negative, of each depends on what quadrant the angle terminates in. So in our first quadrant, both sine and cosine are positive, which means that so are all the other 4, tangent, cotangent, secant, cosecant. In our second quadrant, cosine is negative, and sine is positive. They're opposite signs, which means that in the second quadrant, anything that involves cosine is going to be negative. So that would include secant, tangent, and cotangent. But sine and cosecant would be positive. In our third quadrant, both sine and cosine are negative because x and y are both negative. That means that tangent and cotangent will be positive because they are both a ratio of sine and cosine, and negative over negative is going to give you a positive, but the reciprocals of sine and cosine are going to be negative. So secant is negative, and so is cosecant. And in our fourth quadrant, x is positive, y is negative, so cosine is positive and sine is negative. That will mean that anything that involves sine is going to be a negative value, and that is going to include tangent, cotangent, and cosecant. And the reciprocal of cosine, which is secant, is going to be positive also, since cosine is positive. All right. Also, in our prior knowledge, we have learned that secant, cosecant, and cotangent are the reciprocals of our sine, cosine, and cotangent, not respectively there. Secant is the reciprocal rather of cosine, and cosine, here we're dealing with our angle K, which means, so 13 is the hypotenuse regardless, but if we're dealing with angle K, then 12 is our adjacent side to angle K, and 5 is our opposite side. So secant, which is the reciprocal of cosine, then cosine is going to give us adjacent over hypotenuse. So this would be hypotenuse over adjacent, and that would give us 13 over 12. Cosecant's the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite, which gives us 13 over 5. Cotangent and tangent are reciprocals. Tangent is opposite over adjacent, so cotangent is adjacent over opposite, which gives us the 12 over 5 ratio. All right, and I point that out because we're going to be talking about secant, cosecant, and cotangent, and we'll use their reciprocals, cosine, sine, and tangent, respectively, this time to get those values. All right, we have done reciprocal identities for sine and cosine, giving our cosecant and our secant. We also now need to talk about what we call quotient identities. Quotient identities allow us to find tangent and cotangent using our unit circle information. Remember, only sine and cosine are in our unit circle. So the other 4 trig values we have to get using identities and the values of sine and cosine, or sine and or cosine, in our unit circle. So the idea here is that here we have this right triangle, and this is inside our unit circle. We can see it's the unit circle because the hypotenuse of the right triangle is 1. That's the radius of the unit circle. And we know that x is the cosine of angle theta and y is the sine of angle theta. We also know that tangent of an angle, here angle theta, is opposite over adjacent. But if y is our sine value and x is our cosine value, then we can conclude that tangent, which is opposite over adjacent, also in a unit circle situation, has to be equivalent to sine over cosine. So tangent of angle theta is the sine of angle theta over the cosine of angle theta. And then since cotangent is the reciprocal of tangent, flipping the ratio here then gives us cotangent, which is shown here. So cotangent of an angle theta is the cosine over the sine of that angle. We're adding those identities now. So super important, know our quotient identities for tangent and for cotangent. And the reciprocal identities that we will be using here will specifically be cosecant is 1 over sine and secant is 1 over cosine. The other reciprocal identities are shown here, but we won't need them in this lesson. All right, so let's take a look at a problem. So here it says we are to use the unit circle and our trigonometric identities, the ones we've just been talking about, to find each exact value. So again, no calculator here. You can use your unit circle for a reference right now if you need to. Again, I recommend whenever possible to test yourself on these types of problems and then verify with your unit circle to see if you are thinking correctly about it. So here we want to find the secant of pi 6 radians. So secant is not part of our unit circle. Only cosine and sine are, cosine being x and sine being y. So there are a couple of things here that we need to realize, and that is that we're going to have to use a reciprocal identity. So secant, remember, is the reciprocal of cosine. One of the things that I've shared with you previously is to help you remember which one goes with which. It's an S and a C together. So since secant starts with S, its reciprocal starts with C, which makes it cosine. So this would be equal to 1 over the cosine of pi 6 radians. So now it's necessary that we know what the cosine of pi 6 radians is. And that would be our 30 degrees. And remember, the sine of 30 degrees, or pi 6 radians, is 1/2. And with a 1/2 is always a root 3 over 2, positive or negative. But pi 6 radians, which is 1/6 times pi, is in our first quadrant. And that then makes this positive, which gives us 1 over root 3 over 2. Now, it is expected that we put this into simplest form. So basic math here, really, with some number sense. When we're looking at 1 divided by a fraction, what actually number sense, what turns out is that we always get the reciprocal of the denominator fraction. So for example, if I take 1 divided by 1/2, that would be 1 divided by 1/2. Division by fractions is multiplied by the reciprocal, and that gives me 2, and 2 is the reciprocal of 1/2. If I take 1 divided by 2/3, that's 1 divided by 2/3, which is 1 times 3/2, which is 3/2, and 3/2 is the reciprocal of 2/3. So using that number sense, we can say that 1 divided by root 3 over 2 is going to be 2 over root 3, the reciprocal of that fraction there. And then we have to rationalize. So if you need to, you can multiply by a ratio of 1 and actually write that down. If that's not necessary for you to do, then you can just rationalize, write it in its rationalized form. The other thing is to make sure your conclusion is clear. So remember that all of this work was towards figuring out what the sine, or rather the secant of pi 6 radians is. So your conclusion should be the secant of pi 6 radians is 2 root 3 over 3, like so. All right, let's take a look at another problem. So here we're looking at secant of pi halves radians. So again, secant and cosine are reciprocal, so this would be 1 over the cosine of pi halves radians. I am hoping that at this point you are starting to recognize your quadrantal angles. Pi halves is a quadrantal angle, meaning remember that its terminating side is on an x or part of the x or y axis. And cosine being x, this would be 1 over 0. And so what we're looking at here is making sure we understand our number sense. So again, I want to take a moment, share some number sense ideas here. So we know that 6 divided by 2 is equal to 3. But how could we check that mathematically? If you recall, if we take 2 times 3, we should be getting our dividend of 6, and we are. 2 times 3 is 6. If we take something like 8 divided by 1/2, same thing would be true, because 8 divided by 1/2 would be 8 times the reciprocal of a half, which is 2, which is 16. And if we take a half times 16, half of 16 is 8, which is our dividend. So I point that out because when zeros involved, you want to be super, super careful that your number sense makes sense. So here, if a person said that this was equal to 0 and they used that number sense check, they would realize their thinking isn't correct, because 0 times 0 is not equal to +1. So that tells us that that is not going to be possible. And since nothing times 0 equals anything other than 0, we have to realize that, oh yeah, this is what we call undefined. We cannot divide by 0. So that tells us that our secant of pi-halves radians is going to be considered an undefined value, like so. And when we get to graphing our trig functions and we graph secant, we will realize that what this creates at this x value of pi-halves radians is a vertical asymptote. All right, let's take a look at a practice problem. So pause your video here, please. Give this one a try, and then start the video when you're ready to check. All right, let's take a look at our answer here. So hopefully you came up with square root of 2. We're looking at our secant of pi-4 radians being 1 over the cosine of that angle. The cosine of our pi-4 radians is root 2 over 2. 1 divided by that would be the reciprocal. Rationalizing gives us 2 root 2 over 2, and then hopefully remember that 2 would be a common factor because this is 2 times the square root of 2, so the 2 is reduced to 1, and 1 times anything is that value, so we get square root of 2. All right, try this one, please. Let's take a look at our result here. So this one, hopefully you got -2. Again, we get for secant of 2 pi-thirds, 1 over the cosine of that angle. The cosine of 2 pi-thirds is -1/2 because we're in the second quadrant, and x is negative in quadrant 2. 1 divided by -1/2 would be the reciprocal of -1/2, which is -2 over 1, which is just -2. All right, let's add this example to our notes. So now we're going to look at cosecant. So we have the cosecant of 5 pi-4 radians. So here we have to realize that cosecant and sine are reciprocals. So this would be 1 over the sine of 5 pi-4 radians. 5 pi-4 is in our third quadrant, and sine is negative and our y value. With anything, remember, that has a denominator of 4, we're looking at our pi-4 radians, which is 45 degrees, as our reference angle. So we're dealing with our root 2 over 2 for both sine and cosine. We just have to know if it's negative or not. And here sine would be negative because we're in quadrant 3. So this was 1 over negative root 2 over 2. That would be the reciprocal of negative root 2 over 2, which would be -2 over root 2. Rationalizing, that gives us -2 root 2 over 2, and then we can reduce. -2 divided by 2 is -1, so we get negative square root of 2. So we have cosecant of 5 pi-4 is negative square root of 2. All right, another one. Here we've got cosecant of pi-halves radians. Again, best thing I can do is to warn you to not make assumptions about your quadrantal angles and assume that you're going to have a certain type of value from those quadrantal angles. Always do the math and think about the number sense. So with our cosecant here, we're going to have 1 over the sine of pi-halves radians. Pi-halves radians, which is our 90-degree angle. Sine, again, is our y value, so that's actually 1. So here we get 1 divided by 1, which would be 1. So if you were expecting us to get another undefined, like I said, don't assume. So we have the cosecant of pi-halves radians is equal to 1. All right, and next, practice problem. So again, pause please, try this one, and then come back to check. Let's take a look at our result. All right, so hopefully here you got 2 root 3 over 3. So our cosecant is 1 over the sine of our 2 pi thirds. Sine of 2 pi thirds, which is in the second quadrant, and sine being y would be positive, should be a positive root 3 over 2. 1 divided by that is its reciprocal, 2 over root 3. Rationalizing gives us that 2 root 3 over 3. Another practice problem to try. Pause here. All right, let's take a look at the result for the cosecant of pi. Hopefully here you did come up with undefined, because the sine of pi is 0, and if you'd said 0, remember 0 times 0 is not 1, so that number sense wouldn't make sense. So that gives us our undefined ratio. All right, adding this example to our notes, please. Tangent of 3 pi fourths. So here, tangent is the reciprocal of cotangent, not very helpful. What we have to use here is our quotient identity. And we have to remember that tangent is sine over cosine. So this becomes the sine of 3 pi fourths radians over the cosine of that angle. And each one of these then, we have to make sure that we get the right values in the correct places. With the fourths, quite honestly, it's not as huge of a deal, because with anything with a fourths, again, we're going back to that first quadrant. Pi fourths is our reference angle, and that's our root 2 over 2 for both sine and cosine. So we have to know what quadrant we're in, though, to know whether we're going to get a positive or a negative. So 3 pi fourths, we have to realize, is in our second quadrant, where sine is positive and cosine is negative. So sine would be a positive root 2 over 2, and cosine would be a negative root 2 over 2. Now, you might realize here at some point that you are dividing a number by its opposite and what that result would be. If you realize that, great. If you don't, then you go through your basic math. This would be our numerator of root 2 over 2 divided by our denominator of negative root 2 over 2. That becomes our root 2 over 2 times the reciprocal, which is negative 2 over root 2. And our root 2's we can reduce to 1s. And our 2 and our negative 2 we can reduce to negative 1. So that gives us a negative 1, which of course is what we get when we take a number divided by its opposite. So our tangent of 3 pi fourths is equal to negative 1. All right, moving on. Let's take a look here at our tangent of 7 pi 6 radians. So again, we're looking at, remembering our quotient identity would be the sine of 7 pi 6 over the cosine of 7 pi 6. Now this one we got to be a little more careful, because with pi 6 in our first quadrant, that's our 30-degree angle, and so we've got a sine of 1/2 and a cosine of root 3 over 2. So we got to make sure we get them in the right places. We also have to remember whether we're positive or negative. So that's dependent on the quadrant of our angle. 7 pi 6 is in our third quadrant, where sine and cosine are both negative. So the sine of 7 pi 6 is going to be negative 1/2. And the cosine of 7 pi 6 is going to be negative root 3 over 2. Personally, right here, I would say, okay, a negative divided by a negative is a positive. And just look at this now as 1/2 divided by root 3 over 2. That would be 1/2 times the reciprocal of our root 3 over 2, which is 2 over root 3. You can either multiply straight across and then reduce, or just reduce your 2's right now, which makes it a little easier. That's 1 over root 3, and rationalizing, that is root 3 over 3. So our tangent of 7 pi 6 is root 3 over 3, like so. All right, let's see what else we've got here. All right, cotangent. So now, one thing that you got to be super careful about is with your tangents and cotangents, remembering which quotient identity goes with which. So I'm going to share with you a little way to help make sure you remember. Cotangent, as a ratio of sine and cosine, has cosine in the numerator. So this is cosine of pi halves over the sine of pi halves. And so cotangent starts with c, and its numerator of cosine starts with c. The same thing is not true for tangent, because tangent has sine in the numerator, and they start with different letters. So cotangent begins with a cosine over then sine. So pi halves radians, again, back to that quadrantal angle, which is equivalent to our 90 degrees. Cosine of pi halves is x, which is 0, and sine of pi halves is y, which is 1. So here, number sense again, use it to check. 0 divided by 1, we should say, is 0, and then number sense checking, is 1 times 0 equal to 0? Sure is, so we know it makes sense. So our conclusion is cotangent of pi halves radians is 0, like so. All right. Here we have cotangent of pi 6 radians. Nice little simple one, quite honestly, in our first quadrant here. So again, cotangent, which starts with C, would have cosine over sine. And here, again, pi 6 radians is our 30 degrees. Sine of 30 degrees, we remember, is 1/2, which makes its cosine √3/2, both positive for the first quadrant. So this is the √3/2 times the reciprocal of 1/2, 2/1, which is the square root of 3. So our cotangent of pi 6 radians is the square root of 3. All right, probably some practice problems coming up here, I think. Yep. Pause your video and then come back to check your answer for this one. All right, let's take a look at our result. So hopefully you came up with the tangent of 4 pi thirds is the square root of 3. So we have sine over cosine this time. 4 pi thirds is in our third quadrant where sine and cosine are both negative. With a denominator of 3, remember that means that our reference angle is pi thirds in our first quadrant, which is our 60 degrees. And remember that if sine of pi 6 is 1/2, that makes then sine of pi thirds that √3/2. So sine of 4 pi thirds is negative √3/2. And then to go with that, with the cosine, we get a negative 1/2. And that becomes our negative √3/2 times the reciprocal, which is negative 2/1. Negative times negative is positive, giving us that positive √3/2. All right, let's see what else we've got here. How about cotangent of 0 radians? We know that's 0 radians because there's no degree symbol. Pause here. All right, let's take a look at the result. So hopefully you came up with undefined on this one. Cotangent is cosine over sine. Remember, cotangent starts with C, so its numerator starts with the same letter of C. And cosine of 0 radians is 1. Sine of 0 radians is 0. 1 divided by 0 is undefined. Nothing times 0 will equal 1. All right, I think that might be the end. Yep. All right, so this ends our lesson, and you can go ahead and start your assignment. Have a great day.